Hi, I'm Mrs. McTaggart and we are watching video 7, the penultimate video in the circle topic at Higher. This one is about intersecting circles and this is tricky, but if you can get your head around it and visualise what's going on, it's really not too bad. And quite often it's like a little feeder bit of a question. So I need to look at these scenarios with you. These are the 4 different situations that can happen when we talk about intersecting circles. We can find if 2 circles intersect at 1 point, 2 points, or not at all. And to do it, you have to compare the distance between the centres to the radii, plural of radiuses, whichever way you want to say it. I always struggle with that word. So here are your 4 scenarios, right? Let me just zoom it a little bit. It's easier to prove the touching ones first, so I'm going to look at the bottom 2. And I always think about this when I'm trying to decide what's going on, right? So I'm going to look at this one in particular. If 2 circles touch, then the radius plus the radius of each circle equals the distance between the centres. So for example, if I zoom away in on this little example here, if I told you the radius of this circle was 1 and the radius of the circle here was 2, then the distance between those centres must have been 3. So if radius 1 plus radius 2 equals the distance between the centres, they touch, okay? But what you have to be aware of is, what about the scenario like this, when they touch internally? So what I should have said is that was touching externally, okay, on the outside. It's like a snowman. They can also touch internally, like this picture here. And this is one that you don't always spot. You can also subtract the radiuses. Now what happens if this one's harder to draw. If I told you the big one had a radius of, let me think of a number to work. If I told you this big one had a radius of 3, right? So that red line equals 3. And the little one had a radius of 1. So this little one had a radius of 1. Then this would also be a little radius of 1. And then that little gap in there would also be 1. Okay? So if I did my radius of the big one, take away the radius of the little one, would be 3 take away 1. And the distance between the centres would be 2. So they match. So if the distance between the centres matches the radiuses subtracted, then these circles touch internally and they lie inside each other. It's a lot harder to draw and illustrate this one. Okay, then I'm going to take you to the other 2 scenarios. So I always assume the touching scenario where radius 1 plus radius 2 equals the distance between the centres. If you work out the distance between the centres and it works out to be bigger than the radiuses added, I always think about my 2 little radiuses. They have been touching. So I think that they have been touching like this. But the distance between the centres is too big. So it's like my circles have been pulled apart. So they've been stretched apart. So let's do some little number examples. So let's say this was 1 again. Where's my pen? So let's say this little radius was 1, this was 2, but the distance between the centres was 4. That's bigger than 1 plus 2, so they've been pulled apart, so they don't touch at all. And then the final scenario to get your head around is this one here, where they intersect twice. So again, I think, right, if radius 1 plus radius 2 equaled the distance, they'd be touching. But if the distance is smaller than radius 1 plus radius 2, it's like they've been pushed together. Alright? So let's look at some examples. So before I go into big examples, I'm going to do just some very little kind of illustrations of what's going on again. So I've got radius of a circle is 5, radius of another circle is 3, distance between the centres, the 2 centres is 9. Do they touch? So we go in and we do R1 plus R2 equals 5 plus 3 equals 8. Right, and then the distance between the centres is 9. So my distance between the centres is greater than R1 plus R2, right? Because 9 is greater than 8. So if they were touching, the distance would be 8. But the distance is bigger than that, so they've been pulled apart. So the scenario is here, so they do not touch. Okay? Excuse my messy writing today. So you've got this scenario here, you've got one like that, and you've got one like that. they do not touch. So this is your radius of 3, this is your radius of 5, and then there's a little gap in there, a little gap in the tiny middle bit of 1, because that's what's making the distance between the centres be 9, because it was 1 too many. So they've been pulled apart. Example 2. We've got a circle with a radius of 6, a circle with a radius of 4. So you do R1 plus R2 equals 6 plus 4 equals 10. Now that matches. So the distance between the centres, normally I write distance between the centres. So the distance equals radius 1 plus radius 2. So circles touch on the outside. This is my snowman situation. So they touch externally. So you've got your radius of 4. You've got a bigger circle with a radius of 6. And your distance between the centres is 10. So they're touching, snowman scenario. Okay, example 3. Radius 1 plus radius 2. So R1 plus R2 equals 12. Your distance is 10. So the distance is less than R1 plus R2. So remember, if they were touching, the distance would be 10. It's less than that. So they've been pulled together. So the circles overlap. But the word we use is intersect. So circles intersect. And that's the scenario where you've got this circle and this circle here. So they are intersecting, right? So one with a radius of 7, one with a radius of 5. The gap between them is 10, so they've been pulled in a wee bit. Okay, and my last one, radius 1 is 10, radius 2. So if you add them, you get 18, which is nowhere near the 2, but a quick check, look. R1 minus R2 is 10 minus 8, which is exactly 2. So because the distance equals the radius is subtracted, these circles touch, but they touch on the inside. So they touch, excuse me, my writing, they touch internally. So you've got a big circle with a radius of 10, a smaller circle with a radius of 8. So this would be 10. The smaller circle would be 8. And then there's that little overlap of 2 in the middle there, making the distance here, that little bit there, be 2. Right, let's do some real examples with real circles, real equations, okay? So explain why the circles touch each other externally. So here is your method. For every question, even if you're not sure about, oh God, are they touching on the inside or the outside? What you can do is just get the centre of each circle, get the radius of each circle, find the distance to the centres. If nothing else, you've picked up lots of marks. So that's what I've said there. Get the centres and the radii, radiuses. Get the distance between the centres, and then the compare is the bit people struggle with. So for circle 1, that's the easy one. That's got the centre of 0, 0. And your radius is the square root of 9, which is 3. So I'm calling this one circle 1, and this is circle 2. So circle 2 has a centre of 14 halved, and change the sign gives you 7. There is no y letter in there, so that's 7, 0. And your radius is the square root of, remember you've got g squared plus f squared minus c. So g squared would be your 7 squared, so 49. F squared is just a 0, and then you've got minus 33, which gives you root 16, which is 4. Right, the distance between the centres, so I'm just going to write distance centres down here for shorthand. Oh, that's terrible writing, I'm really sorry. So distance between the centres is, well, you can clearly see, if you compare the x coordinates, it goes from 0 to 7, so it's 7 squared. Compare the y coordinates, it's just 0 to 0, so 0 squared. So you've got the square root of 49, which is just 7. If I go back and do radius 1 plus radius 2 is 3 plus 4 equals 7. So my distance between the centres, this is my conclusion about my comparison, equals R1 plus R2. So the circles touch externally. Okay, that's like your snowman situation like that. They touch each other on the outside, because you'd have 3 to there, 4 to there, which is a distance of 7. They're my favourites. Same again for number 2, just different kind of circles. So each one we're going to get the centre of this first one. So it's the opposite of the brackets. So it becomes positive 5, negative 4. And the radius is the square root of 25, which is 5. For the second circle, centre 2. So minus 14 halved is 7. Change the sign, becomes positive. Minus 18 halved is 9. Change the sign, it becomes positive. My radius will be the square root of my g squared plus f squared minus c, which in this case would be 7 squared, so 49, plus 81, and then it would be minus 94 for the c. And this gives you the square root of 36, which is 6. Now the distance between my centres will be, compare the x's, so 5 to 7 is 2, so 2 squared. Compare the y's, minus 4 to 9 is 13 squared. So that is 4 plus 169, which is square root of 174. Now, we need to go work out what that is, which is 13.19, just for reference. So sometimes you have to go to a calculator. Okay, quick comparison. So R1 plus R2 equals 11. So my distance between the centres is greater than R1 plus R2. So the 11 is what the distance should be if they touched. My distance is bigger than that, so circles have been pulled apart. So the circles do not intersect. What you've got there is you've got a circle for a little picture with a radius of 5. You've got another circle with a radius of about 6. And you've got a little gap in there of roughly 2.19. Now the pictures aren't necessary, but it's worth me doing them just to try to explain what's going on. Okay, next one. Prove that these circles touch internally, my favourite. So first one is your easy one. Centre is 0, 0. And radius is 2. You always like one like that, easy marks. For the second one, your centre is half of 6, change the sign is negative 3. Again, I've not put a y on this one, so we've got another 0. My radius will be the square root of 3 squared, so 9, plus 0 squared, and then take away minus 16, so this becomes plus 16. If I did take away, it would have been a negative, and I can't square root a negative, which gives 125, which is 5. Right, my distance between the centres, quite short working here, so I'll do my distance between the centres, excuse my writing again. So distance between the centres is, comparing the x's, you've got the square root, you've got a distance of 3 squared. There's no distance between the y coordinates, so I'll just put it in anyway. So the distance between the centres is 3. Now, normally do R1 plus R2, you'd get 7, but at a quick glance, R2 minus R1 is 5 take away 2, which equals 3. So the distance between the centres equals R2 minus R1, so the circles touch. And this is the one where they touch inside, so they touch internally. And that's all you have to write to prove it. You don't need to draw a picture for that one at all. Right, I have a final example, okay, my final one. We need a calculator for this one. Same again, but now to show that these ones do intersect. So we're going to do our centres and our radiuses. So centre 1, half of 8 change the sign, minus 4. Half of 4 change the sign, minus 2. Our radius will be square root of 4 squared is 16, 2 squared is 4. And minus 38 turns into plus 38. So we have the square root of 20 plus 30, so square root of 58. Which doesn't simplify, so it's going to be 7.62, I think I got it to be. The same again for circle 2. So centre 2, this is a bit easier. Change the sign, so 4, 6. My radius is root 26, which is 5.10. Then I have to get the distance between the centres. So the distance between the centres equals square root, right, from 4 to minus 4 is 8. So 8 squared. From minus 2 to 6 is also 8. So 8 squared, which is the square root of 64 twice, 128. Which is 11.31. Okay, so now the compare part. So radius 1 plus radius 2 will be 7.62 plus 5.10. So what's that? 12.72. So my distance between the centres is less. No, it's not. Silly me. You know what it is? Distance between the centres is 11, which is less than 12. Is less than radius 1 plus radius 2. So that means that obviously remember that 12.72 would be the touching value. We've got less than that, so circle centres have been pulled together. So the circles, they overlap, but we say intersect. Okay, and that is your kind of intersecting like this scenario. This was a lot. I'll be honest, it's a long video, but it's really important that you can get your head around this and visualise what's going on. So I like to spend a lot of time with it when I'm teaching it. Listen, I hope it's helped. Thanks for watching. Bye bye.